Benzoic acid can be prepared from ethyl benzoate. Ethyl benzoate is first hydrolyzed in alkaline conditions. A student uses the following method. They add 5 centimetres cubed of ethyl benzoate, which has a density of 1.5 grams per centimetre cubed and an MR of 150, to 30 centimetres cubed of 2 molar sodium hydroxide. Add a few anti-bumping granules and attach a condenser. Heat the mixture under reflux for half an hour, so heating without loss due to evaporation. Allow the mixture to cool to room temperature, and then pour hydrochloric acid on. That's going to convert the salt that we've just made here, the benzoate salt, back to the acid. And then we're going to filter off the precipitate under reduced pressure, and that's a hint to a required practical technique where you're using a Buchner funnel inside a reduced pressure flask that's connected to a pump. This is not a very good diagram, but you could do better in an exam. Why would we have anti-bumping granules? Why do they prevent bumping during reflux? Well, they allow the formation of smaller bubbles, prevent large bubbles. So either to say prevent large bubbles or allow small bubbles to form. We now have to calculate using those numbers that are highlighted. So what would our mass be of ethyl benzoate if we had 5 centimetres cubed at 1.05 grams per centimetre cubed? So that's 5.25 grams. And then they gave us the MR, so the moles of, let's say what we're calculating here, the moles of ethyl benzoate would be 5.25 divided by the MR, 150, and that is 0.0350. Let's calculate the moles of NaOH, slightly easier, volume times concentration, but do remember to convert your volume into decimeters cubed. So 30 times 10 to the minus 3 times 2, this is 0.06. And now if we look at the equation, it should be 1 to 1, but we can see that 0.06 is bigger than 0.0350, so NaOH is in excess. Didn't have to double anything. Suggest why an excess of sodium hydroxide is used. Well, we'd use an excess of one reactant to make sure the other completely reacts. So to ensure all the ester reacts, or in this case, if we want to be specific, is hydrolyzed. Suggest why an electric heater is used rather than a Bunsen burner. Well, because most organic things are flammable, so it's likely that the ester in this case, or did it mention any other organics? The ethanol that we produce at the end are flammable. We wouldn't want to use a naked flame. Why is reflux used? Well, reflux is going to prevent the vapours escaping. So prevents the vapours escaping the flask. It's going to ensure that they all get returned to the reaction mixture. So it's I suppose we need to be specific that it's reactant vapours, not products. So sodium benzoate, so we just scroll back up. Now they gave us sodium benzoate. If you struggle to turn that into a structural formula, you could just copy it. I know that the benzene ring is C6H5, and then we've got that COO minus Na plus. We're reacting with the hydrochloric acid to give us the benzoic acid, C6H5 COOH, NaCl as our other product. Suggest why sodium benzoate is soluble but benzoic acid is insoluble. Well, look, this is ionic. Ionic things are soluble. So sodium benzoate is ionic. Benzoic acid can hydrogen bond from the Q group, but benzene ring is insoluble. And then the question continues. After the solid benzoic acid has been filtered, it can be purified. So this is a hint back to the required practical. So how do you do recrystallization? So you would dissolve the solid, in this case the benzoic acid, in the minimum, that's important, you want to be a saturated solution, you don't want it to be hard to get back, the minimum amount of hot solvent. Okay. You often, if you can, would filter whilst hot to remove insoluble, so the bits that didn't dissolve, insoluble impurities. Then you would cool it down to recrystallize it. And then you're going to use your Buchner funnel. So you're going to filter under reduced pressure. So you're attaching it to a vacuum pump. Washing with cold solvent to remove soluble impurities. And then dry. And the last little bit of the question here says, in a similar experiment, a student started with 0.04 moles and made 5.12 grams. So 5.12 grams of the acid. So we need to go back, we need to check whether they gave us the MR, and if not, we're going to need to add it up. So if we go right back to the beginning of the question, we weren't given the MR of benzoic acid. So we did write our equation, we did get our formula. So remembering that benzoic acid was C6H5COOH. So we add that up on our calculator and we're going to get 122. So you type that on your calculator and you get 0.042 moles. That's how much you actually made, and you theoretically should have made, if you started with 0.04, 0.04. Now this is a weird one because normally this would not happen in a percentage yield calculation. You're getting a percentage yield of more than 100%, but this is the correct answer that they want you to give. And then they want you to say, why did the student get this yield that's not 100%, that's more? And probably the most likely thing is they missed that last step, and their sample's full of water still, and the water is very heavy, so they've got water in their product. It could be that there's impurities, but with such a big percentage yield, it's very likely to be wet.